Hey, Jody here with WeldingTipsAndTricks.com. This is part 2 of the gravy TIG welding video. You know, I got about 50 parts to weld and there's 2 ends on each one. So what I'm going to do here is a quick recap of part 1. We did a little manual welding with no pulse, straight current, feeding the wire, and then some lay wire using some different pulse settings. Then on the second flange, we're gonna walk the cup. Also in this video, we're going to talk about feeding the wire with the other hand. You know that other hand that always struggles to catch up to the torch hand? We're going to talk about feeding wire today and 2 or 3 different ways to do that. And so what happens when you use different cup sizes and different flow rates and all that stuff. Let's do it. All right, I started off with a number 8 gas lens, about 140 amps, no pulse or anything, using 3/32 wire, just dipping in and out at a rate of about once per second. And that turned out pretty good, but not 100% good. And then I went to 135 amps, a little lay wire weave. That didn't really give me the look I wanted. Then I went to 1 pulse per second, manually dipping the wire. That looked pretty good. Then I decided to try something else. 50% pulse time, 40% background, 1.5 pulses a second at about 190 amps. And that wound up being the go-to, the setting that I did the rest of them at, because it looked nicer than the rest. So I just used lay wire. I laid that wire right in there and pulsed right over it, and that wound up looking just like that. Well, let's take a quick peek now at the difference in the outcome of the weld in using a number 5 clear quartz cup versus a number 18. That's 1 1/8. So 5/16 versus 1 1/8. I generally set my flow meter to maybe 13 to 15 CFH with a number 5 cup like this. No higher than 20, that's for sure. You don't get any better coverage with 20 than you do with 15, but you know, flow meters are different and things are different depending on how far you extend your electrode. But you can see with this weld, a lot of oxidation. It wrinkled up. It's nothing wrong with the weld, but there's just a lot of oxidation. Now let's take a look at this big old cup. It's an 1 1/8, and I'm using probably somewhere around 45 to 50 CFH on this cup. Now, there are certain materials like titanium, Inconel, stainless steel where it's worth it. You just have to spend the money, but this is carbon steel. It's just a waste of money if I try to use that much argon or that big a cup for this job, because I have no requirements for here. So I settled on a number 8 cup on about 20 CFH, and it did just fine for the remainder of the job. All right, so for this flange end, it's got more mass to it. I've cranked it up, that Everlast machine, all the way to the max, 210 amps, 1.5 pulses a second, 50% on time, 40% background current, and that worked pretty darn good. But I still had to prop my hand, and it was kind of fatiguing to try to maintain that position. So I decided for the rest of it, even though this worked out really well, looked really nice, I'm going to walk the cup on the rest of the pieces. So I'm going to walk the cup now using this positioner, but before I do that, let's talk about feeding wire, because even though I'm doing lay wire right now, I've already done a little bit of feeding the wire and dip, dip, dip. And if you're using a positioner, you've got to not keep up with your torch hand, but you got to keep up with the positioner. So this hand is always last to keep up. It's slow to learn. Usually when you're learning how to TIG weld, you start off with a torch in your hand without any filler wire, and then from then on out, this hand is struggling to keep up. Well, here's how to get some practice there to keep this hand up with this hand. I had a friend who told me of a cousin of his that hired on as a roofer, and he couldn't keep up with the other guys. So what he did was he set a bucket of roofing tacks next to him on the couch, and he practiced flipping those things with his fingers so that he could keep up with the rest of the guys. Okay, next time your wife or girlfriend wants to watch some chick flick like Titanic or The Notebook or some BS like that, cut you off a piece of wire, you know, deburr the ends for safety's sake, yeah, like you're going to do that, and sit on the couch and practice feeding wire. Now you might be tempted to take this and run it through the eyeball when you're watching The Notebook. Don't do that. It's unsafe. Train. Get some training time in on the couch. All right, let's take a look at a few methods on how to feed wire. Okay, this is basically my go-to method. Okay, pinch the wire between my index finger and the finger next to it, and then alternately pinch it between my thumb and my palm there. And this this has a lot of stroke, so I can feed a lot of wire like this, and I especially use this if I'm making long runs on welding aluminum where you feed a lot of wire. Now if I'm welding uphill, vertical, T-joint, something like that, I need to position my hand differently. That other method's kind of like awkward, so I might do something like this, pinch the wire between my pinky and the finger next to it, and then alternately push it with my thumb and index finger. Same concept. You're pinching with one part of your hand and you're moving the wire with the other. I'm pinching it between my fingers and my palm and then just moving it with my thumb and index finger. Now this might be good for certain positions. It just all depends on what you're welding, so you need to know different ways to feed the wire, and so you might want to practice different ways. This is kind of like a itsy bitsy spider method. It's kind of a two-step method. I'm alternately moving my finger and my thumb up, and it's kind of slow go, but if you're only feeding a little bit of wire, it works great. Again, the go-to method for me is this, and the main reason is just because it's got a long stroke and I can feed a lot of wire really fast. You'll also want to practice with both hands. There are times when you have to swap hands and you need to feed wire with a hand you're not familiar with, so getting some practice and building those motor skills pays big dividends in the long run. Alright, well, we're going to chuck up the parts and weld that other end now and tack them up and walk the cup. So really I only need 1 or 2 tacks on some of these, and depending on how sloppy the fit is, if it's a fairly tight fit, I'll just put 1 tack on it because it really can't go anywhere. Now walking the cup is primarily used for pipe welding. I'm going to show you a little old clip here on a 6G pipe weld, second pass, also called the hot pass. That's where it really shines, is on pipe welding. Also putting a root pass in, an open butt root pass like this, is more like wiggling the cup, where you just wiggle really quickly and hardly any side-to-side motion. It just provides a really steady torch motion. And then there's a job that I did welding these new journals in a shaft here. That walking the cup just seemed to work really well. It was a 2-pass job. Ran 1 pass in there, just wiggling it like that, and then a second pass over top of that so that a radius could be cut in there. Now, like I said, sometimes walking the cup's not permitted because it leaves scratches, but since this one already had those knurled marks anyway, it was going to be machined off. Several thousand's going to be taken off, both diameters. That was fine. And it's just easier, less fatigue on you. So let's do this. Let's walk the cup on these pieces. Get a little shot of that. It's more like just a very subtle motion, wiggling the cup back and forth fairly quickly, and that, with just a little bit of pressure between the cup and the piece that you're welding. Especially if it's smooth like this on machine surfaces, it just lets the cup slide along at even increments and gives you a nice smooth travel speed. In this case, my positioner is limited to only about 1 RPM, so it works out just fine. Keeps up with the speed of the positioner, no problem, and gives me a lot more even weld than I would have normally. Here I've got about 2.7 seconds of downslope tapering off, and that is the final product there. Close to 50 of these parts, so now I've got them all kind of segregated in buckets and pretty much ready to deliver. Now, one question I get a lot when I post videos like this of job shop type work that I do here and there: how do you know what to charge? Here's the starting point, and it's only a starting point because there's a lot of unforeseen circumstances, and the more you know about the job, the better off you'll be. But for one thing, on this particular job, I knew that the tolerances weren't that stringent. Like, for instance, the end pieces that I was welding in there, each piece had pretty much close to 50 thousandths extra material on it that was going to be machined off after all the welding was done. So if one piece tilted a degree or two from distortion, no big deal. It's going to be machined off and faced off anyway. Also, I know that it's going to be painted, so I don't have to worry so much about perfect argon coverage and all that stuff. But by and large, on TIG welding jobs around Atlanta where I live, I start at $1 an inch plus $1 per tack. Now you can only guess how many tacks it's going to take. So on a job like this, I would have to assume on a round part that it's going to take 4 tacks per weld, because that is generally worst case scenario. So on this job, the part is almost 2 inches in diameter. So I'm going to multiply that times 3. Pi is 3.141. I don't have to worry about the 0.141. 3 is close enough. 3 times 2 is 6. 6 inches of weld per end. That's 12 total inches of weld plus 4 tacks on each end. That's 8 plus 12. That's 20 bucks. 20 bucks per part. That sounds a little high, maybe to some people. Maybe it doesn't sound high at all to some people. All I know is I'm happy with it. The customer's happy with it. I turn the job really quickly, and that's the main thing sometimes. All right, well, now it's time for the commercial pitch. I did save it to the end, so you can bail if you want, if you got a problem with commercial pitches. But every year I put together the previous year's videos from YouTube and put them on a 4-disc set. It usually takes 4 discs to get them all on because it's a whole lot of content. It's 4 discs. It's a year's worth of work. You can see it at weldmonger.com. Hey, thanks for watching. We'll see you right here next week.